Hello, good morning, good evening, everyone.
Good evening, sir.
Yeah, good evening.
Good evening, sir.
Okay, so we will wait for a
Good
few more
evening, sir.
so more student can join. Then we will start. Okay.
Sure.
Hello. Yeah, once again, good evening, everyone. So first we will take the ER diagram part, then takes the activity and the practice session out. Okay. So how many of you watched lecture 4.1 and 4.2? Please raise your.
Evening, sir.
Yeah, good evening. Yeah, there are 3 participants. Okay. So we will start. Arup sir, to you.
Yeah, sure, Pradeep. Thank you. Hello, everyone. So let us go for it. So we'll start with the ER diagram, right? So is it visible? The screen is visible to you?
Yes, sir.
Okay, okay. Okay, so can anyone tell me what do you mean by a data model? Because we are talking about database modeling and all. Anybody? What do you mean by a data model? Data modeling.
Yeah, that is basically like define various entities, like which models the real world objects.
So all
And
the modeling are going to capture the entities, or it is specific to ER models?
it is for the year model.
Generic, what is the data model, or why I should do a data modeling? So data
Because we must
modeling,
know like how, yeah, go ahead.
data modeling basically try to capture the logical structure of a database. It's basically to capture the logical structure of the database. So it capture all the concepts like how effectively your data could be stored, it could be manipulated, or it could be structured. So these concepts are basically considered within a modeling. So whenever we talk about specifically about the ER modeling, entity relationship modeling, it comprises of two things. One is entity, another is relationship. One is entity, another is relationship. So we can say a ER modeling consists of two things or collections of two things. One is entities, another is relationship sets. Relationships. So anybody, what do you mean by entity in an enterprise? Right. So we are basically looking for modeling an enterprise in terms of logical structure in a database, right? We want to capture the entire functionality of an enterprise in terms of a database in a logical structure. So what do you mean by entity? The entity could be anything belongs to that enterprise which is distinguishable for other things from other
Hello.
things. Yeah.
Sorry to interrupt, sir. Are you writing on any slide? Because your slide
No,
is.
I'm not writing. I'm not writing
No,
anything.
you're on first slide only, right?
Yeah, we are on the first slide.
Okay, thank you.
So entity is basically something which is distinguishable from one another and having a set of attributes. So if you look at an organization like us, where we are having the two teachers, students, etc., etc. So me being an entity, I'm having certain attributes. You also being an entity having certain attributes, and we are distinguishable by our attributes values, right? So you are having a specific name, I am having a specified name. So that way, we can say we are all different entities, right? Now, the relationship looks for how these entities could be associated or related to each other. So there are two things, entities and relation. So from them, we derive another two things, entity sets and relationship sets. What is entity set? The collection of similar kind of entities. The entities having the similar kind of attributes. Suppose all of you, all of the students who have joined the session, they share a common kind of attributes, like if suppose they are having a particular roll number, email address, name, right? So I can say your big an entities, you belongs to the same set, and you create an entity set that I'll call as a student entity set, right? So each instance of the student entity set will be called as an entity. So you're a particular entity of the student entity set, right? Suppose myself, Piyush or Pradeep, we are a teacher, suppose an instructor. So we create an entity set called the instructor entity set. So myself is an instance of a particular entity or a particular entity of the instructor entity set. So this basically specify we are having entities and entity set. So can anybody tell me in terms of a table? So you have created a table, right, in database. So what do you mean by entity set and what are the entities? Suppose you are creating a database using your SQL. So what specifically an entity set and what is an entity?
So table is an entity set and the rows in it are instances.
Each
or
row is an entity, right?
entity in it. Yeah.
So suppose I create an employee table which is having certain attributes like employee ID, name, salary. So that gives a structure who can be and belongs to that entity set called employee. So the table structure of the schema is the entity set. But each row basically an information about an entity or an employee. That's basically an entity. And what are attributes?
Table heading is the attribute.
Yeah, that columns, right? The columns of your table are the attributes, right? So if somebody knows the object-oriented programming, can somebody tell me in terms of object-oriented program? If you don't know, don't bother. But if somebody know object orientation, can you tell what is an entity set, what is an entity and what is an attribute?
Yeah, entity is kind of a like object.
Yeah.
And member variables are the attribute, like
Okay.
member variables in
Instance
that
variables.
object are
Yeah.
attributes.
Yeah. And
And entity set is the probably the class.
class. Yeah. Our entity set is the template, right? Or the blueprint.
Template.
How the entities will look like, right? Entities are the objects and the attributes are the instance variables or the member data members, right? Okay. So that's the initial concept. Now, what relationship capture how entities of an entity set will be related or associated with the entities of another entity set. So how they are related with each other, right? So that is captured by a entity set, right? Sorry, relationship set. Other than you are having attributes. So we'll mainly focus on the diagram today because those theories are there on the slide. I think you can understand well. So I'm not going into much details over there. So as and when they will come, whenever discussing the topic, we'll discuss that. So first term, we are having something called as a strong entity set instead of writing as an entity set. So remember the entity set could be of two kinds, a strong or a weak entity set. So normally an entity set which is distinguishable from others, normally called as a strong entity set. Like you are a student, right? So a student is a strong entity set because you are distinguishable by a roll number given. I am an instructor and I am a distinguishable because I'm having an attribute called the employee ID, which differs from other entities from me, right? So that's why a strong entity will having a certain identifying attribute which will differentiate between all its entities. Okay. So now there could be two different kind of representation whenever we go for a ER diagram. One kind using this rectangle, what you can see. So you put the entity set name like a student over here. Sorry, give me a minute. I'm using my pen tab after a long time. So just bear with me. Yeah. Anyhow, so this is my student. So student is the entity set name, which is having the attributes enrollment number, name, and contact number. The alternative representation, we put this entity set name in a rectangular box and these are your attributes. The underlined attribute is what? Anybody? The underlined one?
Primary key.
Is the key attribute. Yeah, it is the key attribute. In terms of ER diagram, I'll call it as a key attribute. But whenever mapped to a table, a key attribute becomes a primary key. Whenever mapped to a table, it becomes a primary key. It's actually a primary key, you can say, right?
Yeah.
So now in a simple way, please.
So entity set, a table and relation. All the three are same thing or different thing?
Entity set.
Entity set, table and relation.
Okay. Okay. Relationship is an instance of relationship set, which tells you how two entity set could be related, right? Entity set is a thing which belongs to your enterprise, a thing or object you are representing as a pictorial way. That's an entity set, right?
Relationship, I'm not asking relationship, relation. What we call in the SQL.
Oh, you're calling
relation.
it. Okay, okay. These are different terms. So whenever I represent it a pictorial way in a ER diagram, we call it as an entity set. Whenever we represent a schema in form of a schema diagram, normally we refer it as a relation. Whenever these entity sets are converted into the tables, we call them as a table. See, this is a design.
Actually,
right?
yeah. Actually,
this is a design.
All the three are same, but design is different, right?
No, just try to understand. Whenever we are designing a software, what we'll do, we'll go to our client, we'll say, what is your specification, right? We'll take the specification, then we do a pictorial design. That's basically the ER diagram we do. So that's a pictorial representation. It's a logical view. So whenever we keep it as a logical view, it's called as an entity set. But entity set has to be actually implemented in terms of a table. So there is a specific way how this entity set could be converted into the table. It may not be straightforward relationship entity set directly is a table. We'll come to understand that, right?
Okay.
And relation is same thing as a table, but normally whenever we talk about schema, we called it as a relation. Whenever really we create the database, like instead of using the, this is just terms like schema related with relation. If I say database, I'll call it as a table. Just terminologies, but this entity set is the designing part. Table and relation is the implementation.
Got it, sir. Got it. Please proceed. Okay.
So now, whenever we are implementing it as a table, it's a simple way. We'll have a student, which will have this enrollment number. I'm not writing the entire thing. This name and this contact number, right? So this is a simple way I can present my table, and this will become my primary key, right? Anybody, any doubt?
No, sir.
Okay, so I'll proceed next. Now, these attributes are called as a simple attributes. These attributes called as a simple attributes because each takes an atomic entry. Like name, a single name. Every student will have a single name, right? Every student will have a single enrollment number. Every student will have a single contact number. This is my assumption. Each value entry is a atomic. But whenever we consider that we'll have certain attribute which are composite attribute, which is composite attribute. Please do this correction. This is not a composite key. Composite key is a separate thing. Composite key is a primary key which consists of multiple attributes. So this is composite attribute, right? Please do the correction. Okay. So what is a composite attribute? Whenever I'm having an attribute which is having subparts, it is not an atomic entry. It is having some subparts. I'm saying the student is fine. Student is having an enrollment number as a key attribute. Contact number is another simple attribute. But name is a composite attribute. I mean to say the name having three parts now, which will have a first name, middle name, and last name. So this is the way we represent it using this kind of ER diagram symbol. We give a tab over here to represent the subparts. Whenever we go for this kind of presentation, this is the name, and name is having this the subparts of the name. So name is having three parts: F name, M name, and L name. The question is how? Yeah.
Can you give any example? Taking a table. I mean, I wasn't able to comprehend this sub attribute. I mean, if we take a student table, so far we have seen in any of the table we practice, we have seen.
You're telling how I'll convert it into a table, right?
Yeah, yeah.
What should be the table representation? Yeah.
Yes.
So
yes.
composite attribute, whenever we convert it into a table, so it is the standard way we do. We'll have the student as the table name, then enrollment number. Right. Now, instead of putting the name over here, we'll directly put the parts. F name, M name, L name, and contact number. So this is the table presentation. So this is only for the logical representation, but whenever we implement it in a form of table, so we get the parts directly as an attribute of the table.
So when the composite attribute, when you talked about, so it is actually a composite key, right?
No, composite
I mean,
key is a kind of a primary key which is having different parts, right?
Sir, composite key doesn't necessary to be a primary key, right? Isn't it?
Compound key and composite key is the same thing, right?
Yes.
Compound key you read, no?
No, sir. In the first week, sir has explained about keys, where he spoke about composite key, and
I think he didn't told about composite key. He has mentioned as was compound key. Can anybody clear from the instruction team, instructor team?
I think it was more candidate key and super key.
Yeah, candidate key, super key is fine, right? Candidate key.
Compound key. It was compound key, sir.
It was compound key. Compound key is a primary key which consists of multiple attributes, right?
Yeah, multiple
It's the
attributes.
same thing. Compound key and the composite key is basically the same thing. But composite attribute means an attribute consists of subparts, right? So whenever I say the term key, it's having a different kind of functionality. You have to understand.
Okay.
You can check out again. If you still have a doubt, you can just put it on the discourse. But I think I'm correct. What I'm saying.
Arup sir,
Yeah.
I think he is confused about the attribute key and a composite key and composite attribute. So
No, I told that. No, composite
yeah.
key is nothing but a compound key. Means it's a primary key having more than or a second sorry or a what you called that a primary key having more than one attribute, right? And composite attribute means it's an attribute which is having subparts.
So, is it something like when we do select F name, M name, L name as name from table student from student?
No, you cannot do that. You have to use a concatenation operation because inside the
Yeah, yeah.
database there is no entity called as a M name. No, there is no entity called name.
As there is no entity.
No,
So, we
so
will
you have to artificially, synthetically, you have to create it by concatenation or doing. So that's not part of our database. So we are putting the parts separately. That's the way we manage the composite attributes.
So, sir, like this composite attribute name, okay,
Mhm.
the way you have written that student and in that student relation, you are putting this first name, last name, and
Yeah.
the other name, right? Middle name.
Yeah.
So, is it not will it not be a good idea, like if we separate that out in a different table and reference that with a foreign key?
Don't you think every time you want to query about the name, you need to do the joining, which is an extra effort?
Okay.
So rather than you can take just the F name, M name, and L name, and if required, we'll do the concatenation on the application level. That's the easier thing.
Okay.
Getting my point? Yeah.
Yeah, makes sense. Yes.
Yeah.
So just a quick question.
Yeah, please.
Is there a name for the left-hand side picture that you've got and the right-hand side, the one which has the tree-like structure? Is there a name for these two representations?
Yeah, there is a name, right? Here also name, there is a name.
No. What I meant is it called something like you have the student and then you have enrollment number, name, and so on, like a box?
Means
on the
this
left-hand side?
notation name.
Yeah.
Notation name I cannot right now remember. I have to
Okay.
check
Okay.
out, right? Yeah.
Okay. Sure.
I cannot remember like they are having a name or not, but I'll check out. I'll tell you.
Okay. Sure.
I cannot
Thank you.
remember right now. Okay. Then how to handle your multi-valued attribute? So again, it is an attribute. Okay. So multi-valued attribute means an attribute can take multiple values. So composite, the attribute having different parts. But our attribute, if it's supposed to store multiple values, then we call it as a multi-valued attribute. Suppose we consider a particular student can have more than one contact numbers, right? So it's not atomic or a simple attribute because a student is associated with more than one phone number, right? So how do I present this multi-valued attribute? We put it inside the second bracket in case of this kind of presentation. This is here, it is put into double oval, right? So this calls a multi-valued. Now question is, how do I handle it in terms of table? Anyone?
Listed, it may be put in a list.
Put in a list. Is it a good idea?
It could be another table altogether, right?
Okay. So first question is, suppose I'm having the student, enrollment number, F name, student first name, M name, the middle name, L name. So up to this, we don't have any confusion. Now, if I know there are 3 contact numbers exactly, I can have contact number 1, 2, 3. But nobody is telling like a composite attribute. I know there are 3 parts exactly, but nobody telling for a contact number how many contact number I'm going to have, right? So what could be the
Yeah.
idea?
Hmm.
Anyone?
Create another table. With,
Create another table, right? So I can have the student
Key value pair we can have.
contact number, enrollment number, and contact number. Now for here, for the first student table, we have directly got this enrollment number as a primary key. No issues. But for the student contact, whatever the next table I have created, now this enrollment number can be repeated because if I'm having an enrollment number 101 and I am having 3 numbers, suppose I am having a number 1, 2, 3, 4, and I'm having another number 8905. So for each of the contact number, my enrollment number has to be repeated, right? Because my entries are atomic. So which can be
Yeah.
the primary key here?
Composite key.
Combination of both.
Combination of both. That's always correct. But in few cases, you may only make the contact number as a primary key. Can you tell me in which case?
If you don't allow the same number to be given.
Yeah.
to the students.
So me and you never have a common contact number. Then it's fine. We can have a contact number as a primary key. But if there is a situation, my and my brother both are belongs to the same institution and both are sharing the same contact number, then it has to be a composite or compound key, right? So it is always safe to make this as a composite key. Does it make sense?
Compound key. Composite.
Yeah, compound or composite, it's the same
Yeah,
thing.
same
Right?
thing.
That's a better idea, right?
For this particular table, a student contact or the whole
In
student
general,
table?
in general.
Okay. In general, yeah.
Because I
Compound key
don't
will
know
be
if this the second attribute is a shared or not. If I have,
yeah.
I'm well confirmed that that is never been shared, then it's fine. Otherwise, like suppose your email address, maybe you can have multiple shared email address, but you are very sure your email address is not given by anybody else. See, in that case, you can make your email address only the primary key. That does not matter. But it is safer that your enrollment number and email address both creates your primary key, so that if your email address is used by somebody else, they are also not face any problem, right?
Compound key will be more suitable.
Suitable, yeah. But in cases, you can also use that contact number if you can ensure it is not shared by somebody else. Getting my point? It's basically depends
Yeah,
on the
that is
application.
risky. That is risky.
Yeah, that's
Maybe
risky. That's risky.
yeah,
Yeah,
we
it's
may not
application
remember
dependent.
whether it
Yeah.
has been used or not.
Yeah. Okay. Next, we are having something called as a derived attribute. Something
Sir,
called
one
as
thing, please, one thing. Can you
Yeah.
go to the previous slide?
going. Yeah.
Yeah, here in the rectangle, we have written contact underscore contact number in the curly bracket, and
Yeah.
here is the double
Yeah.
ellipse.
Yeah.
Is it some relevant notation?
Yeah.
In
If
the
I'm
curly
using
bracket
this
and
kind
this,
of notation, then use this particular. If I stick to this kind of notation, we'll use the second bracket. If you go for this
Okay.
kind of notation, we'll go
the
for
curly bracket represents this double ellipse, right?
Yeah. Yeah. Both the same
Okay.
thing. Yeah.
Okay.
So corresponding thing is represented. That's why every time, like
Yeah, got it.
this is how
Okay.
we have composite attribute. This is how we'll have composite.
Okay, fine.
Now
Thank you.
derived attribute. Derived attribute is something if the attribute can be computed from another attribute on the particular entity set rather. Right. So suppose if you look at this particular entity set, you are having two attributes, date of birth and age. Do you need both the attributes to be stored in the database?
No.
It's a waste of storage, right?
Yeah.
Because if I just store the date of birth, I can calculate the age, right?
Yes.
So what should be good idea? What I should store?
Date of birth.
Only date of birth, and whenever required, I'll calculate the age format, right? So now this age, which will be called as a derived attribute, and it is basically look like a function here. We say age, then open close parenthesis, and here it is a dotted oval. You use a dotted oval.
Yeah.
Right. Now, what should be the table structure? Anyone? If I have a student, I'll have enrollment number, which is the primary key, first name, middle name, last name, and we'll have student contact number, which will have enrollment number and contact number, which is a composite key. And here I can only keep
Date of birth.
age. It's not a good idea to put a derived attribute inside a table because it's just a waste of storage, right? I don't want to store anything which I can calculate. And one more thing, does the age remain fixed?
No.
So is there any point I'll store it in the database? Because every year age will change, right? So I need to have a system that every year my table will be updated. That's again a problem. But DOB, if you check for, DOB is something fixed. You don't have to change in a lifetime of a person, right?
Yes, sir. Yes, that is fine.
So that's why derived attribute you do not keep into the table. Please keep it in your mind. Derived attribute we do not keep inside the table. Okay. Now we'll look for the relationship set. So
suppose
this is
we required to keep this date of birth and age both. Then we have to keep both. Like in some cases, some people do not have their date of birth in earlier time.
no, that's entirely a different situation. So
Okay.
that could be handled in a very different way.
Okay. Fine, got it.
Right.
That will be a different situation. Right.
Yeah. So that's not an ideal case over here to be considered.
Okay, fine.
Okay. So relationship or relationship set. So this basically represents a relationship set, which represents how entities of this will be related to the entities of this. How the entities of the student entity set will be related with the entities of the course entity sets. Right? It represents a relationship. Now, why you call it as a relationship set? Anyone?
relationship set.
It says how it is connected with another relation.
I can have many entities, no, S1, S2, S3. Here I can have many codes C1, C2, C3.
Yeah, we will
It
have
basically
derived
represents
entities we will get out of this
yeah,
relation.
it's basically present how they are mapped to each other. It represents a mapping, right? So I can say student S1 has gone for code C1, student S1 also got for code C2. I can also say student S2 gone for a course, sorry, the C2. S1 gone for a code C2. I can also say S2 is also gone for C2, right? So it basically represents a mapping between entity of these entity sets and entities of these entity sets. So that's why it represents a number of relations, right? Each of these is a relation. So that's why it's called a completely relationship set. Relationship sets. Now, it also represents as a cardinality constant, which say how many entities of this entity set will be associated with the entity of this entity sets. Again, I repeat, the cardinality constants say how many entities of this particular entity set will be related or associated with entity of this particular entity set. Now, in this particular scenario, what do you think? What could be the relation? So you can see a student can take more than one courses, right? Because S1 has two courses, C1 and C2.
Yeah, 1:n.
Okay.
No, it is many to many because
It's a many
one
to
student
many,
can-
right? Yes, yes. Because C2 course again taken by how many people?
Many students.
In
Two
number of
students, right? Two
Yeah.
students. It's called a many to many cases, rightly, or end to end cases, because end to end. Because I want to say any number of students can take a particular course, or a course can be taken. What I told, any number of students can take a course. Any number of students can take a course, or any number of courses can be taken by a student. Any number of courses can be taken by a student. Am I clear?
How many total possibilities?
How
Suppose
many
n number
total
of n number of students are there, and
Yeah,
n
tell
courses
me
are there,
how many
or
possibilities could be?
m courses are there. N into m or n into m plus
It's
n into m
basically the same
into n.
thing, or you can just say
N
m. If you don't mark anything, it's say end to end. You can have any number of associations. It's a zero
And
to
n into m.
it's a 0 to n, or it's actually from 0. We can have no students taking a particular course,
Yeah, that is all.
or a course having no students. That also possible, right? So what could be the table representation for this? Anybody? First,
What is the?
table presentation. How do I convert it into a table? A number of tables. First
Okay,
question is how
like
many tables are required? How many tables will be required to represent it?
Two.
Three.
like one more table is required actually.
Okay, let us
Like
draw
apart
one
from
by
student
one.
and course, one more table.
Okay,
Like
so let
where
us
you
have
will
student, which will have the student number. I'm making this all shortcuts, right? Student name. I can have course, which will have course number and course name. So the
Okay, we
primary
need
key.
one more,
But how this relationship could be represented? I have to
yeah,
create
one
another
table
table,
like yeah,
enroll,
student number and
student-
course number.
the student
which will
number,
have the
student name,
primary keys, which will have the primary
Okay.
keys from both the tables, and the
Yeah.
primary
Yes,
key will be a
composite key.
composite key. Because I can have here S1, S2, S3. Here I can have SC1, C2, C3, and I can have a mapping S1 taking a course C1, S1 also taking a course C2. I am taking S2 also taking a course C2. So I cannot make Sn, that student number, as a primary key because it is repeated here. I cannot take course number also as a primary key because it is repeated here. But their combination is never repeated. See, their combination is not repeated. Right? Does it make clear?
This is the rule to select the primary key. Suppose-
It is intuitive
suppose-
also, right?
It is intuitive. There is no fixed formula. It is intuitive based on the condition
Yeah.
where we are
So we fetch
implementing.
all the primary keys from the corresponding associated tables and create a new table, right? You take the primary keys of the entity sets and create a new relation, right?
Okay, fine.
Now question is, can I remove anyway this enrollment table and put the information in this table or that table?
Pardon, sir?
Can I remove the enrollments table, this enrolls table, and put the
Yeah.
same information either in the student table or in the course table? Is it possible?
Okay.
No, sir.
No, right?
No, it will
I
like for
lose my primary key, right?
Yeah.
yeah.
I lose my primary key because both has to be repeated, right? The student number and the course number, right?
Yeah.
So I have to go for 3 tables only. So remember, whenever we have this kind of situation, I need minimum 3 tables, right?
But sir, for like if it is a one to many, in that
No, I
case you
haven't
can
gone for one to many. I'm on end to end.
Okay, okay.
I'm on end to end.
Okay.
I haven't talked about. It's explicitly written over here, many to many, right? So I'm on many to many situation. This entire slide is. I can see there are something on the chat. Somebody from the instructor team, can you find out anything important on the chat? Okay. One more thing. So we got 2 kinds of representation. So in practical scenario, always you'll find we use this particular kind of representation, but this is also important. Say whenever we are having this kind of relationship, how do I represent on the second way, the first way, that what representation we have, that a student is written as this, right? A student is written as this, which is having the student number, which is having the student name, and a course we are having, right? We are having
Course
a
number, course name.
with the course name, number, and course name. So these are underlines, right? So here also we can present a relationship, but here the relationship has to be given like this. It has to be a dotted line. Then you create a box, enrolls. This dotted line, this dashed line, not dotted line, says this is a relationship. This is not another entity set. Although this is not so much required, this kind of presentation. So this is the equivalent representation of this. So if I give a solid line here, it looks like this is another entity set, right? To represent, this is not an entity set, this is a relationship set. We use a dashed line. Okay, how this one is different? Anyone?
Date is different.
It has date.
So what does it
Yeah,
signify?
Relationship has an attribute.
Relationship as having an attribute.
Additional
So
attribute.
it also keeps the information that when a particular student got enrolled to a course. Can you give another example of the similar situation? Where we need an attribute for your relationship set.
Employee department, sir.
Employee department, what should be the relationship attribute? Joining date maybe, right? When he has joined that particular department, right? So these 2 tables remain the same. It's the student. I don't write it again, right? It remains absolutely same. Now what will be changed? This enrolls table. So what will have? Enrolls tables will have the student number, course number. These are the composite key, and
date.
the enrollment date.
Enrollment date.
So this attribute which is belongs to the relationship set, which becomes a part of the tables which belongs to the relationship set, right? It's a simple, right? Everybody getting?
Yes.
Yes.
Any difficulty?
Only additional
No.
attribute has been added in this, right?
Yeah. Just add it. Please let me
No,
know
no,
if you are
sir,
facing a
from
difficulty.
where the date will be entered, or somewhere it will be extracted from somewhere. It is not
No,
there
it
in the
has to be
table.
entered. These are the tables, no? So suppose you
How
are
this will be
enrolling for the
derived?
DBMS course. So your
Date.
information is already there. The course information is already there. These are already there. The moment you register for your entire program, BSc data science or BSc this thing, so your student information already there, the course information already there. So there will be only a certain entity. Suppose you are the student number S1 and you are enrolling for the DBMS, which is having an ID C3. Suppose you are entering on this date, so this particular data will be entered.
Okay.
Done.
Okay. At the time of the creation, it will
Whenever
automatically
you are
fill that.
enrolling for the course, just the entry will be made, right? Done.
Yeah. Automatically it will create, right? Okay.
Yeah.
Okay. Thank you.
Okay. Now we have a one-to-many situation. So how do you understand
Many
one?
to one. Many to one.
Sorry, many to one. Yeah. Which side is one?
Course, yeah, the course side is one and
Both sides.
student side.
So another alternative way to represent, you can have this. This side is dot dot n. You can have dot dot one.
One. Yes.
0 to 1. It's at most 1, not exactly 1. It's at most 1. Please keep in your mind it's a at most 1. Right?
Yeah.
So what does it means?
It may be 0.
It may be 0 also.
Yeah.
So a
Some
student
does not select for any course.
any course, yeah. The
Okay.
student can enroll for at most one course. A student can enroll for at most one course. But a course can have 0 to n number of
Many
students.
students.
But how is it possible, sir? Some student is not
No, just it's
enrolling
an
for any course.
example.
Okay.
No, there could be an enterprise where it allows to take only one course, right?
Yeah.
Maybe. Just it's a logical scenario. I'm not taking a particular case, right?
Okay. It may be 0 also.
Yeah. So there can be a course where no student got enrolled, or there could be a scenario where the particular course having hundreds of students, right? But in this particular case, a student can opt for at most one course. Is it okay?
So cardinality, what will be the cardinality constraint for this?
Cardinality many to one, no? N to one.
Yeah. And how many? Suppose M.
N could be
students is
anything.
there.
N could be anything. We say many. N. We don't specify the number because we
Okay.
really don't know, no? In real
fine.
scenario. But we designed the table in a way so that it do not create any problem with my constraint. My constraint should be maintained. That's all. The primary.
Suppose
key
we
for
don't
an
have many to one also, then whether it will clash with the previous one, many to many.
Yeah, I'm
Suppose we
taking
have
that.
many to many
Yeah.
only.
Let us have it.
Okay.
So we are having the student table, which is having the student number and student name, and we are having the course table, which is having the course number and course name. And if you look at the previous, we can have also enrolls table where we can have this S name
Student
and
number
C
and
name,
course number.
which is
Date.
a composite. Okay.
Yeah.
Now the idea is the student number S1, S2, S3, and here I'm having C1, C2, C3. Okay. Now a student should opt for at most one course. So S1 should have only one course, C2. S2 also can have only one course, suppose it is C2. S3 also can have only one course, suppose it is C1. If you have more, suppose S4, yes, C4. S4 also can have at most one course. So it could be again the C4. Is it?
So the course can go to student table as a foreign key.
Yeah, I'm going for that. But does it make sense up to this?
Yes.
Okay. So now clearly it is understandable. This student name is a foreign key which is referring to this, and course name is referring to this. It is true for the previous one also. I may not have shown there the foreign key, but it's true for that also, right?
Hello.
But yeah, please.
Yeah, I have one question.
Huh.
The enrolls table, sir, you have said that it can go, a student can take 0 and at the most 1 course.
Yeah, I
right?
got your point exactly where I'm coming.
Yeah.
You're exactly correct.
So
Just give me a
enrolls-
moment.
Okay.
Give me a moment.
Okay.
Yeah. Now, so up to this is fine, right? We can have foreign key. S number is referring to the student name number, and this is student. Now, suppose I am having also a student S5, which is not opting for any course. Who is not opting for any course? So, what should be the entry over here?
Null.
It should be a null entry, right?
Yeah.
There will be no record.
Sir, S5 won't be there, right?
Hmm?
In the table. S5 entry won't
S5
be
is there, but for the course name,
Null.
It is
null.
a primary key, right? Composite primary key can't be null. S5 null won't be possible.
Yeah, that's the point I'm coming here, right? So the problem comes over here, right? Which I need to address. And one more thing, the previously we have seen, we cannot merge this table either to this or to that, right? But in this situation, can we merge?
What's the pardon?
In previous situation, in many to many situations, we never can merge this enrollment table on the student table or enrollment table with the course table, right?
Yeah.
But can we merge it over here? Please look at the data carefully and tell me.
We can have course name, course number in students table.
We can have the course number in the student table. Why? Because the student number never be repeated, because each student can have at most one entry. Each student can have at most.
Yeah. Condition is that at most.
Yeah, so that's
one.
why the
Yeah,
student number never can be repeated. So why to have
Yeah.
two tables? Rather, I'll suggest what? Remove this table and just have course number over here. And this course number will be a foreign key. But this foreign key allows what? Allows
Null.
Null value.
null, done. And this is the primary key. We do not change the primary key. So my problem is solved.
Only one
So, sir,
student name will be
can you
there
go
in the
back to the
table.
previous slide?
This one?
Yeah, sir. Here also, say for example, if you here the relation is many to many and like 0 to n, 0 to n, right? So if a student doesn't enroll for anything, you will end up in similar situation there also.
No. Look at here. S1, S2, S3, C1, C2, C3. Okay. Actually, I told that to create the problem, actually. Understand the problem. Say S1 is related to C1, right? S1 taking C1, S1 also taking C2, and I'm assuming the S2 is also taking C2. Now S3 is not taking anything. Is it required to put S3 over here in this table? Is there any
No.
need at all?
So the same holds true for the like next page, right? Like if that guy is not taking any course, like say for example,
that is I told, no, that that's agreed. That
if
agreed, you cannot
S5
give
null,
it.
you no need to put that in the table.
Yeah, I got your point. You may not give this at all. But my question is, don't you feel the entire table is redundant?
Yes,
Yeah,
that I understood.
Yeah, so that's why I merge it. And then at the same time, it's also solved this problem, right? So that is I want to point it out.
Okay.
Yeah, here the student name 2 times. Student name will be only 1 time, no? In this. Student name and course name.
Student number only repeat once. So that's why I can keep it as a primary key over here. No,
Yeah, yeah.
I-
Number and name. Yeah.
I don't
yeah,
have
yeah.
to take a separate table and
Got it,
composite
got it.
key.
Number,
And
name, and that.
Some student is not associated with any course. I don't have to bring into the enrollment table only. No, so suppose you are not taking any course, why I'll keep your information inside the enrollment table? That's a simple way. Am I
Well,
clear?
then if we need enrollment table, then we have to derive from this S table, right? Student table.
You have to join your the student table and course table. No, we'll get the
Yeah, based
entire
on the
information.
condition. Yeah, yeah.
It's just a join, right?
Joining.
But
right.
here, just remember the foreign key allows null. That's only thing you have to remember. You have to permit
So
the
sir,
foreign
like
key to be
in
null.
this situation, assume like in the relationship holds like couple of attributes. Okay.
Huh?
So in that case also like
Yeah, I got your point. I'll go for that. Yeah, got your attribute. So here I have enrollment date. So where it will go?
Student table.
Student table. Does it create any problem?
No.
No, it will not
Entirely
create any
whatever
problem.
you will have inside the enrollment table, move into the student table. Done. So
Fine.
what could be your rule? If you try to find a rule, what could be your rule? The primary key of the one part goes as an attribute of the many part, right? The primary key of the one side goes as an attribute of the many side. Is it true?
Yes, sir. Yes.
Yes. So sir, like if that enrollment relation, like in that relation, say for example, you have some attribute which changes,
Yeah.
which can take many values.
It can take many values. So that's a different case. So in
So
that
I'm
case,
just thinking,
table
yeah.
structure will be entirely different. The changes means different. Like your age changes everywhere. That's a different thing. But you're having number of phone number. That's a different case. So here we are not having any such case, because as a student, whenever you are taking the course DBMS, your enrollment date is fixed.
Yes,
Yeah.
say for example, now
Yeah.
I'm not able to like find out a good use case, but like okay, let me ask this way, like if say for example, like in all circumstances, will it be is it a good practice, like whenever there is a many to one, avoid that intermediate
Yeah, it's always
table?
because it removes your lot of
Okay.
redundancy, right? You have to repeat everything in the intermediate table. But in the many to many, we cannot avoid it. That's why we have to keep it, right? If we can
Understood,
skip
understood.
it, why we want to have it, right?
Yeah.
Because every entry inside the student table has to be there inside your entry table, right? That's a problematic.
Fundamentally, many to one means the relation is defined as at least one from the one you have to select.
One side, yeah.
Oh.
The problem is if the requirements in the future change to many, then it's a problem, right? So we'll have to be careful.
That's it. That's as a specification you cannot change. Once the software is developed, you cannot say you have to change the specification.
Yeah, but that's
not a normal scenario.
It means, sir, this schema and this design is before developing the software.
Yeah. So this
We
is
have
you're
to
designing
design
your software. You're designing
because we are opting MVC paradigm, right?
Yeah.
This is
So
the
we are
model. We are
designing. We are
designing.
still on the modeling.
Okay.
That
We are
model is
designing the
different.
model.
MVC model is different. This is modeling means we are designing it. We are getting a logical view of it. MVC modeling is different. That's basically acting as a database, a virtual table kind of thing. But here the concept is different. Here, say, suppose you want to build a building, what you do using pen and paper, you create a blueprint kind of thing. No, what should be the size of your house, what should be the length, what should be the width, something like that.
Yeah,
You're
yeah.
putting it on a pen and paper before you creating the table.
We cannot change it once we
Yeah,
design it.
that's
And
the point, is once you fixed your design, if it is reviewed properly, then you will go for
Okay.
the implementation, right?
okay.
Normally it doesn't change. Yeah, it sometimes has to be changed, but it's a rollback thing, is a very difficult part of it.
Very difficult part, right?
Yeah. So you have to change from the beginning again, everything.
Most important thing is this for us.
This is, somebody please tell me. I'm not going to explain because I think you can understand.
1 to 1.
So what?
So this is
scenario?
in the other side, right? Other side we need to add that attribute.
So a student can have how many instructors?
1.
At
Many
most
names.
one. At most one.
At most
Most
1.
one, yeah.
And instructor can have 0 to n number of students.
Yeah.
And
Yeah.
table structure,
A student can have many and
The student
Hello?
number and the instructor.
instructor can have at most one.
The primary key will have this student number and course number. Or
somebody
number.
told something like, I missed it. Anyone trying to say something? An instructor can have how many students?
At
10
most
number of
one.
it. 10.
Because this is the
yeah,
inside,
yeah.
right? This is the inside. And
Yeah.
the student can have
Instructor.
0 to 1
At
instructor,
most
right?
one instructor.
At most 1.
Yes.
So what is the idea? The instructor table will have, sorry, this is I've done mistake. So this is the
Yeah,
instructor
that's
number.
why this is instructor number should be
Instructor
there.
name.
Yeah.
Yeah. So this will have instructor number, instructor name. This will have the student number, student name, and along with that we'll have the instructor
Name.
number.
Number.
Number is the primary key, right?
Yeah, primary key is
Instructor
So done, right?
number.
Yes, yes.
So you are understanding, right? Okay, so
Yeah.
let's go deeper. This is
1 to
1
1.
to 1.
yeah. So a department can have at most one manager. A manager can have at most one department. Please remember this at most. This is where people make the mistake, right? So how many
Yeah.
tables?
2 tables.
Two tables,
Again, two tables.
two tables only.
One side, any one side arbitrarily you can take it as a n side.
Yeah, yeah.
You can consider this as a one part. This is as a one part and this side as a n part. Or you can also consider this as a n part or this as a. So in both the way it will work. So that means you can create a table where you can take this MGR name number over here. That's one way. Or you can keep the table as it is and you can put your department number over here. Both will work.
So when
Right.
you are putting 0 to n, doesn't it makes it n to 1 to many?
That is the generalized case, right? 0 to n, 1 matlab it's a 0 to n also, right?
No, one department can have one manager, right? And one
No,
manager
it's
can have only
actually,
one.
it is actually 1 to 1. What I'm going
1 to
say.
1, yes.
It is actually 1 to 1. I am saying for converting into a table, you can arbitrarily consider one part is a n and one part
Okay,
is a
okay,
1.
okay.
That is what I'm saying.
Yes, yes. Yes.
Both
For
are possible.
converting into the table, you can treat it like this, but it is 1 to 1.
Sir, so we are creating only one table, right?
No, two tables. I'm showing. There is two way you can create the tables for it. So department table, one way to create DEPT number, DEPT name, and manager. So this is the primary key. You will have NGR number, NGR name. This is the primary key along with DEPT name. This is one way. Another way.
This is also primary key, no? So department number is also primary.
No. It will be repeated, right?
Yeah.
This is the department number, department name, and MGR number, and this manager table will have MGR name, MGR, sorry, name. So both the way it will work. You can either go for this or either go for that. So if you're taking this situation, you're considering your manager is the many part and department is the one part. If you go for this, department is the many part, manager is the one part, right? But both are representing one to one.
So sir, like here, like this relation has two ends. Okay, one is department, another is manager. Suppose there is one more entity like which is related to this same relation.
I'll go
Say
for
for
that.
example,
For the timing, let it be binary. I'll come
Okay,
to that.
okay.
Yeah, I'll go for that.
Okay.
So up to this, is it clear?
Yes, yes.
Everyone,
In
right?
the last line, sir, the manager name and manager number. This was having only two attributes.
See, either you move it over here. This is one way.
Yeah, yeah.
Another way is you move it over here. Just the same thing, right?
Yeah.
Either you put the manager number inside the department table, or
Okay.
you put
Okay,
the
fine,
department
fine.
number in the manager table. Done. Nothing else.
Yeah, fine. But
Means
here,
it is a case of
key
many to
only
one.
only one primary key will suffice.
So a one-to-one relation can be treated either as a one-to-many or many-to-one. A one-to-one can be, for creating the table, can be treated as a one-to-many or many-to-one. Both the way it works. Shall I go
Yes.
next?
Yes, sir,
Yeah.
fine.
Okay. So this double line, it's a complete participation, a complete or full participation, which is represented as a complete. So now I'll rather don't draw it over here. Let me discuss it. So the left hand side, this side says a student will have at least one course. Complete participation means every student has to have a relation. Every student has to have a relation. Is it clear?
Yeah, at least one.
At least one. So every student
Means
should
zero
enroll.
zero is not
Zero
included.
is not an option. It should be at least one.
Yeah, at least one. Yeah.
That is at least one. Every student should enroll for at least one course, right? But this is say what?
Course should have 0 student.
No. This is inside. This is one side, right?
Yes.
Acha, suppose let it simple. Let it be simple. I'm thinking you're confusing. So see, forget about this. It is just like this. Tell me, what is the relation between the student and course?
Many to many.
Where is one to many? The arrow is there on the right hand side, no?
Many to one, sir.
So how do you say?
Many to one.
So a student can have how many courses?
Many courses.
One to n.
At most one, sir.
At most one. A student can have at most one course. A course can have
At
how
most
many?
one.
Yeah.
And one
You are
course
telling
may have many
at least
students.
one, na?
I'm saying about this, what I have drawn over here.
Okay. It
So
is not double line.
Just forget about the double line. First say a student can have how many courses?
One.
Definitely
At most
one.
Or one.
One course.
At most one.
At most one, sir.
A course can have how many students?
Many.
N number of students.
Many.
Many students. In
But now if I put this double line, what does it mean?
Student
A
has
student
course.
will have at least one course. At the same time, student can have at most one course. This double line say at least, this arrow say at most. Is it not?
Yeah.
So what exactly means that?
That means
At most.
only one course.
Student
Student
cannot
will have
exist
exactly
without-
one course. The student can have
Exactly one
Exactly.
course.
exactly one
one
course.
course.
That's the idea, is right? But a course can have any number of students. Please check out, is it correct or not? It's a full participation, means I'm saying student must enroll for at least one course. That's a full participation, this double line say. I cannot say student cannot enroll for, student is not enrolling for any course. A student must be enrolling for at least one course. But the arrow say student can enroll for at most one course. That means a student can
Okay.
enroll for exactly one course.
Hmm.
Yes, sir. It means that all a student is participating, sir, for at most one course.
Yeah.
Okay, with the participation constraint is defining like this, right?
Yeah.
Okay.
So will it make to the change to the table structure? So student table
Hmm.
will have
Hmm.
the primary key of the one side goes into the many size as an attribute. Like
Yeah, student number. Correct.
student name, and the course number, the
And
course it is
course.
enrolling for, and the primary key is this, and course is course number and course name. But any change from the previous one?
Primary key will change.
Yes. Course name is not null.
Course number, which is a foreign key, previously we said allow null, right? Here it is
Yeah,
not
it is
null.
not null.
Because at
It is
it is
not null.
exactly one, right? It is exactly one. So foreign key should be not null now.
Not
You
null.
do not
Yes,
entry
yes.
allow any student without a course. You do not allow any student without a course. Does it make sense? So we are realizing the entire thing slowly.
Right,
Yeah,
right,
yeah.
right.
This is the only change. Not null will
But
be
this is
removed
an
here.
important change. Otherwise, the constraint will go off, right? The participation
Yeah.
constraint will go off if you don't do this.
Yeah,
So this
yeah,
is
yeah.
a small
Participation
change, but very, very
yeah.
important change from the
Yeah,
perspective
yeah.
of attending the constraint.
Sir, so we can't implement the second category of one-to-one table, right?
Can you tell me? I didn't understand.
We can't do it the other way, right, sir? So course number, course name, and student number cannot be done.
No, a course can be opted by number of students. No, so course number will be repeated. Then S1 can have a number of courses, right? Sorry, a course can be opted by a number of. So C1 course can be taken by student number S1. C1 can be taken by S2. So this course number will be the repetition will have no. So it cannot be a primary key, right?
Yes, sir.
Getting my point? If you want to have the student number over here, it may happen that student S1, S2, and S3 all have taken the same course C1. So can you make it primary key now? No.
No, it cannot be.
But it cannot be, can be over here because a student can take only one course only, right? So we can maintain the primary key over here, right? So that's why we have moved on the many side, not on the one side. So everything having a fine logic, you need to understand slowly. Like after the class, you have to write it on a paper. Otherwise, you cannot understand. So you have to see the diagram, try to design it your own, like how the table will be.
Can be a course that no one enrolls in.
This is a complete participation. No, I'm saying the student must be enrolling for at least one course.
No, sir.
If I allow the student not to enroll for any course, then I'll make it allow null, right?
No, sir. I am talking about the course. I mean, there can be a course that no student enrolled in.
Yeah, suppose I'm having a course C3 for which no student has enrolled. This C3 won't come into this table, right?
Okay, sir.
So that means that course is not taken by any student.
Yes.
C3 doesn't have an association means that doesn't take, it's not taken by any student, right?
Yes, sir.
These are very intuitive, but you need to do a lot of practice because it's a difficult thing if you don't practice, because it's basically needs a very, very clear understanding. But if you understand it clear, it's easy, very.
No, here, sir, we are designing on the paper. But how we You will convert into the table exactly.
So these are the table, right? You just create this table. Done. These are actually tables
Okay.
only, no? You are creating.
Okay, the
In
same thing.
database also we create the same tables, right?
Okay, okay.
So this is, I am just showing it on the paper, like how this table will look like. But actually the table has to be created on a database, right? So whatever I'm saying, not null, foreign, you can do it using SQL, right? Each
And
of the things I'm talking
how
about.
many tables will be required based on the condition, situation?
Yeah.
What is required exactly? Then we have to choose such type of situations and put the table, right?
Yeah, your user will give you the specification, right? Then you will draw this ER diagram. Next step will be from the ER diagram, you create the table in your computer.
Okay.
Right.
Here in problem statement, we will get this conditions, right?
In problem
User will
statement,
be
it will be written. In my university scenario, a student can enroll for this many courses.
It will be given like that.
Courses can be taken by this many of student. Yeah, this will be given to you. But then you have to draw the appropriate diagram. That's one part of it. So in your exam also, a scenario could be given and you may be asked to draw the diagram. Or maybe a diagram is given, you may be asked to write the tables. Or maybe diagram is given, you may be asked to tell the specification, like what should be the specification for this particular diagram. So you need to say it gives a scenario where a student can enroll for exact one course, although a course can have any number of students. So this is the specification. So this is the way the questions can be asked, right?
Yes.
So what's the notation for that? This one, 1 is to n and n is to n. I'm a little confused there. So on the left hand side, what will be the notation?
This is 1 to 1.
Yeah,
this arrow side is 1. Non-arrow side is n.
No, in the the subsequent cases. Yeah, in this case.
This is the inside. This is the inside. This is the one side. If you have an arrow, then it's a 1. If don't have an arrow, it's a n.
No, but is it 1 to n? Because you're minimum 1 is allowed, right? Minimum 1 has to be there. Earlier we used to write 0
to 1 only. Say the cardinality ratio and participation constant are two different things. So cardinality ratio says it's a n to 1. And participation constant says the student must have a full participation.
These notations are universal. This double line and universal.
But you are having another versions of notation also, but throughout the DBMS, our course will use this notation.
Okay.
So these are standard notations.
Okay, sir. Thank you.
This is a way 1, or you can also draw it like this. This is another way. If you are writing 1, so writing this and writing 1 is the same thing. Getting my point? Explicitly, you can write a 1, so it's a 1 to 1, or you can have this arrow both the sides.
Okay. Either literally we write 1 or that.
Yeah. So actually, you can also do it like this: double arrow, double line arrow, both the sides, double line arrow. Okay.
Double line arrow and double line 1 is the same, right?
Yeah. So what does it means?
1 to 1.
1 to 1 relation.
Is it only 1 to 1?
Participation constant.
No, sir.
1 to 1 means
definitely 1 to 1. It can't be 0.
It is exactly 1 to 1. So manager
exactly 1 to 1. Yeah.
Manager manages exactly one department. Department should have exactly one manager. Exactly one manager. Now, how many tables are required?
2.
None of them can be repeated now, right?
Yeah, manager
only
and department.
Only one table.
Only one table.
Only one table, I think, suffice, na?
Yeah, but 1 to 1 you need 2 tables. Exactly 1 to 1 you need only one table. Sorry,
only one table.
1 to 1 needs 2 tables, but exactly 1 to 1 can be
it is part of the entity.
Single table. So it's a manager department table. You can have the manager number, manager name, Then you can
Oh.
have this DEPT number, DEPT name, this, and you
Sir.
can make this as a, you can make either this or this as a
Yeah.
primary key, doesn't
Primary
matter.
key, yeah,
Because
yeah.
none will
Primary
be
key,
repeated. Any one you can make as a primary key because none of them will be repeated because exactly one relation is there.
any one of the four, no, sir?
No. Either the manager number or department number. Manager
Because
name can be repeated, right?
Okay, yeah. That, yeah.
Any of these two primary keys can become a primary key.
Any
Either
of the
this or
primary key
this.
can be primary.
Because none of them will be repeated because department number also will have only one entry for the manager number, and manager number also will have exactly one entry for the department number. So
Okay,
any
sir,
of
fine.
them can become a primary key. Does not matter.
Yeah.
But sir, this is complete. These are completely two different entities, right? In the real world. So
Yeah.
is it a good idea to merge these two entities into one?
But what is the logic of splitting a table? What is the fundamental logic of splitting the table? Why we decompose the table? What should be your answer?
The reason we decompose the table is one can change to minimize the number of changes like during update, right?
We basically do it for two things: to reduce the redundancy and to
Yeah.
reduce the anomaly. Right.
Yeah.
On another
Correct.
part, what is the disadvantage of breaking a table? It
Like you need to
reduces
perform a lot of joins, like
yeah, it will
during
reduce the efficiency because every time you need to do a joining. So do you think here you are increasing the redundancy or decreasing the redundancy?
What did you tell, sir? What is the need of breaking this
Decomposition
table?
we do for a table for two reasons. You learn the decomposition in normalization clearly. I'm just telling you in advance.
Okay,
Why we should
decomposition
split a
is a
table?
process, right?
Yeah, why we should split a table into a number of tables? Why don't we have a single table, big table? So the two reasons are: first is to reduce the redundancy. You should not repeat the same thing number of times. And second is the anomalies. There could be different anomalies whenever we insert, delete, or update your data from the table. So this is could be reduced if you do a decomposition. But what the bad thing about decomposition? It's reduce the efficiency of your design because you have to do every time joining to fetch the total information, right? So join is the extra thing. All the subtable has to join to create the total table, right? But in this particular case, if you keep all the information together, does it increase your redundancy? No, it reduces the redundancy. And there cannot be any anomaly in this particular case if you check thoroughly. So why we should split the table and increase the
But say for
joining?
example, you want to change some information in the department table, okay?
Yeah.
Like
Department table, department number can be entered only once. There is no way department number will be repeated, right?
No, like what I'm saying, say for example,
See,
here,
first try to understand. The anomaly becomes because of the repetitions, right? A department number repeated every time. So whenever the department name changes, everywhere I need to change the department name. But in this particular case, a department number will appear in the table exactly once. So how the anomaly is supposed to come here?
see, okay, say for example, you want to change the department name, okay?
Yeah.
You want to change the department name. What you will do? You will take the entire lock on the student manager. You will take the lock on the entire row.
Yeah.
So what does that mean actually? If someone wants to change the manager at that same time, he has to wait for that, right?
Yeah. So what is the problem?
So that means you are losing on efficiency,
But
right?
that is not an anomaly, right?
That is not anomaly. But say for example, what we are trying to do, there are two different, like in real life, there are two different objects. Like we are not separating the responsibilities.
No, you are
See,
going
I am
into the
coming from that
modularity.
object-oriented paradigm.
No, I'm not going to ensure that. Here, my objective in a design, I want to reduce the redundancy. That's my primary objective. Secondary objective, I need to do it in a way so that it will introduce an anomaly. I'm not going into the modularity part. So if you go for the modularity part, that application level part, there could be many issues which comes in the recovery portion, then many issues with this thing. So it's a simple way. Suppose there is a computer science department where I am the manager. Suppose my record has to be deleted, then computer science information also will be lost, right?
Correct.
So that kind of situation we are not right now dealing with. We are basically focusing
Okay,
on
okay.
reducing the, so that application specific situation, right? But we are, whenever we are designing in a generalized way, our primary objective as far as the database is concerned is to reduce the redundancy so that anomaly could be avoided and the storage space could be saved. That's my primary objective as a database designer. So think it as a database designer, not a application development perspective. So from that level, you have to do many changes. Like there could be many situations. Say, I am a only person who is on the computer science. So if my information is deleted, means computer science information is deleted. Or computer science department is gone, means my information will be lost. So there could be this kind of situations also involved. But we need to deal it in a different way. But if you just think about, we need to reduce the data repetition. The primary objective, how much repetition of the data I can avoid. So this is the best case. You're introducing a table in between means something has to be repeated. Am I clear? Hello.
Yeah, like, but not very like convincing at this point of time for me, at least. Like, because, like as you said, like there could be those kind of implications, right? So, for example, like there are certain situations where you need to design a table, like you need to design the ER model, and there, like we are merging these two. Like,
yeah,
I'm not very comfortable at least.
No, you need to tell me why you are not comfortable.
See, like I told you this too. Like this manager, it represents a complete different world, and these designer like a department, they represent a different
see, that
object,
is the
right?
implementation aspect. No, that is the implementation. But see, a particular manager, as I am related with the computer science department, so it is obvious that my information and computer department is strongly related, right? We are strongly related, or we are not separable inside the table because we are having a exactly one-to-one bounding.
I mean,
It is
another way,
exactly one-to-one bounding, right?
sir, another way to probably look at it, just to resolve, is if you're looking at department as an attribute of a manager, then the department clearly has to sit within the manager. Whereas, for example, department is an entity where other employees of the same department are also being mapped to the department. Then, even though there is going to be only one manager, department will
No, you
exist.
told the first situation is correct. Why not see the department as a composite attribute as a manager?
Yeah, so in that case, clearly department will sit within the manager entity itself.
Yeah, so that's a clearer way to understanding, no?
Yeah.
Why not?
So, like if it is a composite attribute, I understand. But since they
No, it's
they
a
two
different
represent
way to
different
present
object.
the thing, right? It's a different way to present the thing.
Anyway, let's move on actually.
No. Is it not a different way to present the same thing?
No, it like when you are modeling an entity like to me is a, like, say for example, if we come from the like object oriented programming paradigm and the best
so
practices,
object oriented,
right?
if you are talking, you are having a has a constraint, has a clause. How do you represent? Say, if I say a manager has a department, if I say clearly,
You take a reference of that.
Has a. I say has a.
But you do not model the reference like a manager within the department class itself. What do you do? Like if you go to the manager, like this kind of things in object oriented, what will do? You write a class manager, you take a reference, that department D, and department you model as a different
it is
class.
an attribute. No, it becomes an attribute of the manager class. No, has a
correct. But department class you are maintaining it differently, right? So that's what.
No,
like
this
you are
managers means of what? I wrote it as a manager, but if you say a manager has a over here, does it clear your doubt? Is it not the same thing? If I say manager departments or manager has a department.
Okay, okay.
Or
so
in
let me
a
ask
reverse
you.
way also, if you see The department having a complex compound attribute, complex attribute as a manager, it also do the same thing, right? If you say a department has a manager, does it make any change?
Okay, sir. Like what I'm saying, like the case, like if you want to write this in a object oriented programming, how many class you will be creating basically? One class or two classes?
I'll create two classes.
Two classes. That means like you are basically telling me you are creating two tables, right? Tables are equivalent to your classes because they are the
No,
entity
you
set,
don't
right?
take it in that way. Like it's a see, it has to be classes. Like two classes means it's a this way. You will have a manager class. So manager class
And you have
having
a
this
department class.
attributes, and within that we are having class which is a department class. Now this department class is a composite thing. So composite thing, how do I represent? We inflated it. So we'll have a manager here table. So inside that we'll have the manager name, number, manager name. Now how this composite thing has to be attribute presented in a table? You just add the attribute of this inside this table. That is how do we do with deal with a composite attribute, right? Say if I have a employee, right? Employee name, employee say EID, employee ID, and say employee name itself is a class which is having the first name, middle name, and last name. So it's a class within a class. So it's a complex. So I can say the employee having a compound attribute, complex attribute, this. So how do I represent it in a table? It's a E having EID. And what are the attribute of the inner class? That will be inflated, like it comes as it is. So the same thing
Yeah, sir,
actually I'm doing here.
Yeah, like you are treating that as an inner class, and like inner class has
See,
generally
you can create
used
it as a
for
two
events.
class, but fetching a member of that inside your class is the same thing basically, making it, declare it outside, make it reusable, means you can again create an instance of it through another class also. If you make it inner, you can use within the outer class only, but conceptually it's the
Right,
same
only
thing.
within that outer class.
Yeah,
Yeah.
so conceptually it's the same thing, right? See, a class within a class, the inner class is nothing but a complex attribute, right? Okay, maybe you can go through once, then Saturday we can still discuss this. Right?
Okay, sir.
Yeah, we are having still some pending part. Yeah. Okay, next is something called as a weak entity. Just forget about this double notations over here, this double diamond and double boxes. Can you tell me what does it means? Anyone?
Mini section, code section. 1, 4.
So what does it means? Just forget about that double lines, what we have. So our course can have how many sections?
Many.
Many. And a section can have how many courses?
1.
One, at most one.
Exactly one, right?
Yes.
Not
Exactly
exactly one.
Yeah.
At most one. At most one.
Is it not exactly one?
Exactly, because double line is there in this side.
Double line and arrow both are there, right?
Correct.
Okay,
correct.
okay, yeah.
The
At
course
least and
can
at
have
most.
any number of section. A section can have exactly one course, right? So a section is represented by a section ID, semester and year. Now this is a typical case. We call it as a weak entity. This section is called as a weak entity. Why I call it as a weak entity? Because a section does not exist.
Earlier ones were the strong entities.
Earlier all we used a strong entity.
Okay. This one is only weak. Okay.
Yeah. So section, here we call it as a weak entity. How do you represent weak entity? This double boxes, right?
Double rectangle.
This
Sir, what
also-
does we mean by this weak entity?
Yeah, I'm telling that. So now,
Okay.
weak entity doesn't have a identifying attribute or a primary key, right? Now, secondly, it is completely depend on a strong entity. Now, does a section exist without having a course?
No, sir.
No, no.
Cannot be there, right? So suppose
Yes.
there is a hotel and there is room. So room cannot be exist if you don't have a hotel, right? If you have building and apartment, two entities, apartment cannot be there without the building, right? So whenever
Yeah.
you are having an entity whose existence is completely depend on having a particular strong entity, that particular entity will be called as a
Weak entity.
weak entity. So whose existence is completely determined
Depend.
by a strong entity. So first course will come, then the section will come. And why I say the section cannot be there? Suppose for each courses we create a section AB. So DBMS course having a section AB, the Java course having a section AB. So here you can have section A, some semester and some year. So definitely there is no a primary key, clear primary key which is defined over here. So what is dotted over here? Dotted line, these are not a underline, a solid underline. This together called a
Dotted line.
discriminator or a partial key. This calls a discriminator or a partial key. This identifies a group of entities, not each entities. Not each entity. It basically identify a group entity. So how the table can be created? See, the course table definitely will have a course ID and title. There is no doubt about it. Where the primary key is course ID. Now
ID.
this section table, what it will have? It will have the primary key of the course table and rest of the attributes.
Section.
Now what should be the primary key? The discriminator along with the primary key of the strong attribute create the primary key for the table. Again I
All
say
the discriminator.
all the discriminator plus the primary key of the strong attribute creates the primary key for the weak entity. Now weak entity, whenever you are having, the existence of the weak entity depends on the string entity. So that is identified by this relationship which is put into double diamond, which says it is an identifying relationship. So the section is an weak entity which will be identified by the course. Without the course, there is no identification of the section. Again, I repeat the meaning over here. This is 1 to n. This is say full participation. This is the identifying relationship. Means this particular entity doesn't exist without having the course. And this double over here, this is a weak entity. Weak entity having the partial key or discriminator, which should be a dotted underline. Now the discriminator along with the primary key of the identifying attribute, or sorry, identifying strong entity, that strong entity creates the primary key for the weak entity. Maybe next day we can go for a much more important or a real kind of example.
This weak entity is the table, no? So section is the weak entity.
Section is the weak entity, yeah.
And the section ID, semester and year.
Is a
all
discriminator or
three
yeah.
discriminator.
Yeah.
All the three at
Yeah,
a
all
time.
three in this case, but you can have a situation where you can have one or two.
Okay. Can you give an example where we can have this situation?
See, suppose you are having a hotel and the room.
Okay.
The room number may be your discriminator for each room. Now, whenever you say this is the hotel number and this is the room number, you can identify which room it is. If I just give you a room number, you cannot say which room it is, right? You need to specify this hotel, this room, to specify a particular room,
Okay.
right? So the primary key from the hotel will be a part of your primary key, and discriminator, which is the room number of the room, they comes together to create a primary key for the room table. So which exactly specify room of which hotel, right? But if you just say a room number, we do not know which hotel is the room number, because the same room number could be there in multiple hotels, right? Similarly, the section A can be there in many courses. Until and unless I add which section with which course, I cannot say like which section it is.
Yes, sir. Correct.
This is still we had up to this we have done all the binary kind of relationship. We are looking into a ternary relationship, right? Where a teacher guides a student on a project, and all are n comma n, n to n, like many to many.
Ternary means more than binary, or
Ternary
three
means
only?
3. Quadic means
Three,
4.
okay.
Means the situation is
Okay.
same
Okay.
for if it is more than binary. And remember,
Okay.
if you go beyond binary, the cardinality constant like 1 to many or many to 1 cannot be easily implemented. For that, there is a different way. I don't want to go for that today. Remember only the things, if you go more than binary, all are many to many. All are
Okay.
many to many. So
Many to many.
a teacher can have many students, a student can have many teachers, a teacher can guide for many projects, a student can take many projects.
So is it compulsorily many to many?
We cannot realize the one to many or many to one in this way. There is another alternative approach. We'll tell you next day. Today we don't have much time to complete that part because it's a difficult concept. I want this to be consumed today, next day, so that we can go
Yes,
for
sir. Yes, sir. Yes,
for
sir.
this
Yes,
kind
sir.
of diagram. It's a many to many situation. One to many or many to many and many to one cannot be realized in this kind of diagram. It has to be drawn in a different way. I'll show that afterwards. Is it okay?
Yeah, yeah. Please explain this one. Ternary.
So can you tell me what should be the tables?
Teacher, project, and a student.
Teacher should have what?
Teacher number and teacher name.
Teacher number.
TN and TN. Yeah.
Student should have. Sorry, student should.
Student number, student name.
Student number and student name. Project should have.
Project number.
Project number, project
name.
Project name.
TN, PN.
There will
And
be a table that will connect all the three.
yeah.
Yeah, one table.
One table we need. One more. That's a project guide. So the same rule over here. The primary key of all the tables come together. So from the teacher number we'll have the teacher number. From the student table we'll have the student number. From the project table we'll have the project number. What should be my
Here only one table will suffice, right?
Yeah. Basically we are having 4 table: teacher, project, student, and a table which is representing the relation between 3. And what should be the primary key for this table?
All three.
All 3.
All the three.
Right. But
Primary
again
key.
I'm repeating, one to many or many to one cannot be realized in a this way. We'll learn it next day. Today I think it's
What is since? Since here.
what is
Since.
Relationship attribute.
Since. In the
oh since. Yeah, sorry I forgot to add it. It's a relationship attribute, so that's sorry, that should be also part of this table, right? Relationship.
Since means date. Since is the date.
Yeah, date. When the particular student
Okay.
is assigned with a project and teacher.
Okay. Got it. The same thing is there, only here conditions are not there, only one table will suffice. So, right.
Okay. I want to make it a bit more complicated. So the entire thing, the teacher, student, and project, their entire thing has to be evaluated by an examiner. Suppose an exam is happening. So I want to introduce an examiner over here. Right.
Somebody
He
is
wants
having a
to-
background noise.
Is it from me? No, it is not from my side. Okay. Okay. So examiner want to evaluate the entire thing. So I'm not saying the examiner will evaluate only the project. The examiner want to evaluate the project, the student, and the teacher. In that case, we have to make this. Is it not?
Evaluate is a table.
Evaluate is a relationship set.
Relation.
Right? A examiner evaluate the teacher, the project, and the student, right?
Hmm.
There
And
is an easy way.
Examiner will be table, no, sir?
So there is a easy way to avoid this complicated situation that's called aggregation. Aggregation say whenever you are having this complicated way, why not treat this entire thing as a single entity? So put it in a box, present it entirely in a entity. So this is not for creating the tables. It do not give you any advantage of creating the table, but it gives the advantage to give a clean representation. Give a clean representation. You can have evaluate by examiner. So basically I mean to say aggregation of all this will be evaluated by examiner. This is an alternative diagram rather than connecting this teacher, project, and student all with the eval. So this calls a aggregation relation. So I'll take out of this. So this is the thing. What I have drawn over there, it's there. So with the evaluate table, I have added one attribute, the date of evaluation, when the evaluation is happening, examiner having an examiner number and the examiner name. Now what these tables will have, the teacher, just quickly, teacher number, teacher name, project will have project number, project name, student will have student number,
student name.
Student name. Okay. Examiner also easy. It will have examiner number, examiner name. Okay. So project guide, what it will have?
Teacher name, student name, and
teacher number, not name, the primary keys, right?
Number. Primary key number.
And since.
Sorry.
Yeah.
I'm making it every time. Since is not part of the primary key. Yet.
Yeah.
And you can understand evaluate also will be a table, right?
Yeah, evaluate
so
will
the
also
evaluate
have a
table, what you should have?
This TN, PN, SN, and data evaluation.
The primary key of this particular relationship.
Yeah, examiner number.
PN.
And
SN,
all the primary key.
Yeah.
PN, SN, TN,
So this is this.
Okay.
Again, I have missed one thing.
Date of evaluation.
Primary key EN.
And date of evaluation. So the primary key of this particular relationship and primary key of the examiner.
Both are primary keys. Examiner name, number, examiner name, both.
No. Examiner number over here, primary key. Here the examiner number is coming, no, as a part of the primary key. Name is not gone.
Here, but in examiner, both are the primary key. Examiner number and name both.
No, examiner number. No, this is only underlined.
Okay, now in the diagram.
Oh, sorry, I have drawn it wrong. Yeah, please correct.
Okay, it is wrong. Okay.
Yeah, I have drawn it wrong. Yeah.
Okay. Okay.
Sorry,
Okay.
yeah.
Okay. No problem.
Please remove that. Because
Okay.
it's
Yeah, okay.
examiner name definitely cannot be a primary key, right? Somehow make
Yeah,
sense.
that's something because yeah. Okay, no problem.
So
Is
the
it
reason
clear?
it's called aggregation, is because we're aggregating that project guide.
Yeah,
for
the
that.
entire thing as a single entity. This entire
Right.
Yeah,
tables
this
and
is
everything
simple. This is
aggregated in
simple.
Excel.
Nothing is new in this. No, it is very simply aggregated.
But do you have any problem? Still?
No, it is fine.
Don't you think this information is project guide is redundant with the evaluate table?
What, sir?
Don't you feel the project guide table and the evaluate table they are redundant?
Yes.
Yeah.
It's repeated.
One I
So,
repeated.
can you have this scenes over here and we can remove this table?
Yeah.
Yes.
Fine.
Please think and tell me.
Unless there are multiple examiners who are going to evaluate the project.
That's fine. Multiple examiner I can handle because it's a composite key, right?
No, I mean per project, teacher, this combination, if there are more than one examiner who's going to evaluate it.
Yeah. That's obviously that we cannot have in this scenario, right? You want me to say the teacher, project, student, the same combination having the multiple examiners? That cannot happen here in this scenario. But other than any,
The date of evaluation should be nullable.
that's fine. I'm not making it primary key. So you are putting a null or not does not matter logically, right?
Then we can make it combine.
But what happen if all the projects which are guided by the teacher and made by the student are not evaluated?
Of
There may be some
evaluation will
projects
be
which are
null.
not evaluated, right? It's a completely understandable, right? What will happen then?
Of evaluation will be null. Examiner will be null because not
But
evaluated.
this is a part of your primary key.
Can assign an examiner number but keep it unevaluated.
No, that's not a good, right? So actually ideal scenario, we need to keep both the table if we have to consider that the projects may not be evaluated. It's not necessary, no, all the projects will be evaluated. You can delete this table if and only if you have this. So I cannot draw the line also. Something is happening with my, it's a 2 line. Yeah, it's a line.
We need to make examiner number as part of primary key only if a project is evaluated by 2 examiners.
No, that's done. That's done means I'm telling only if I have double line over here, then only I can completely remove the project guide table. Otherwise, I need to have a project table. Can you tell me why? What this double line says over here?
Participation.
Complete participation. What that say? All the projects are evaluated, right?
Yes.
If all the projects are evaluated, why I should have project guide table? But if it is a single line, you have to have a project table and a project guide table and evaluate table separately.
Yes.
This double line says all the projects has to be evaluated, right? Because they are having complete participation. But if you don't give this double line over here, that means you need to maintain both the tables. Both has to be maintained. Because you can have some projects which are not evaluated. For them, which project is assigned to which student and who is guide, that information has to be kept, right?
Yes.
But if you can guarantee it is a double line, that means you are forcing all the project has to be evaluated. So in that time, you may not have this table. You can just delete because this is just a redundant information. Because all this information is going to be there inside the evaluate table. Is it making sense?
Yes, sir.
Sure, no?
Yes, sir.
Okay, now last thing, the easiest thing. the generalization and specialization. Basically, they are the both things, both the same things. So I say a person is specialized into faculty and student. So I can say a person can be a faculty or person can be a student. So faculty and students are the specialization of a person, right? So that's I'm taking a top-down approach. I say person could be of two categories. One is faculty, another is student. I'm taking a top-down approach. So I say this is a specialization. But there can be another approach you can take. I can say faculty and student both are person. Faculty and students both are person. This calls a generalization. I'm doing a bottom-up approach. I'm saying student and faculty is commonly called as a person. If you go for the second example, if you say specialization, I mean to say student could be of two kinds, undergraduate or postgraduate. This is the specialization. I'm making specific. If I go for generalization, I should say both the undergraduate students and postgraduate students are students, right? I'm generalizing. If I take a bottom-up approach, I'm doing a generalization. If I do a top-down approach, I'm doing a specialization. Is it okay? Is it okay?
Yes, sir.
You know everyone?
Please, once more, sir. Please explain. Connection.
Okay. So for example, if I say employee, right? I say employee could be a contractual employee or a permanent employee. Then what I'm doing? I'm doing a specialization of the employee, right? Is it not? When I say employee can be of two kinds, contractual and this thing, I'm doing a specialization, and my approach is top-down approach. I'm starting with employee and dividing into two parts. One is contractual, another is a permanent. Is it okay?
Yeah.
But if I take the reverse approach, if I say contractual employees and the permanent employees both are employees, then what I'm doing? I'm doing a bottom-up approach.
Yes, sir. Yes.
And this is a generalization, because if I say just the employee, this is a generalization of permanent and contractual employee, right? So both the terms specialization and generalization is the same thing, but it is the approach. So if I take a top-down approach, I'll call it as a specialization. If I take a bottom-up approach, I'll call it as a generalization. Now, whatever you say specialization or generalization, it can have two forms: overlapping or disjoint. Overlapping or disjoint. First example is a overlapping example. How I represent it, the arrow has to be given in this way, overlapping, and disjoint, the arrow has to be given in this way. Now, why I say it's overlapping? If the situation is a person can be a faculty, a person can be a student, and if I mean to say also a person can be both faculty or student, means there could be a TA kind of post, a technical assistant kind of post, where basically the student also do some kind of teaching also, right? Then I'll call it the overlapping. Like a person can take both the roles, faculty and student both together. But in a disjoint role, a student has to be either an undergraduate student or postgraduate student. A student cannot be both together, right? A student cannot be both together.
Yes, sir. Got it. Got it, sir.
That's also disjoint. This calls a disjoint.
So is the notation correct? Because it looks very opposite to intuition. Overlapping.
Yeah, I got
the
it.
arrows don't seem
but it is like that only. You can check
okay,
out.
okay, okay. So we'll have to think of it the opposite way.
Yeah, it's look like it is adding up over here, right?
Yeah.
Okay, so there is another thing, that's a participation over here. So participation also could be partial or it could be total. It is not complete, it is called total, right? So partial or total means what? A person can be a faculty, person can be a student, and if it is a overlapping, I told a person can be faculty of student both. But partial means a person can be just a person other than anything like a faculty of student. Just a person, right? So I also assume certain roles which are other than faculty or student. Second example also, a student can be an undergraduate student or postgraduate student, but they cannot be both. But there could be a student who is a school student, which not belongs to these two categories, right? So these are called a partial participation. So there could be a student who are just student who are not
Yes, yes.
neither a undergraduate, not a postgraduate student. A person, just a person, neither a faculty, not a student. If the scenario is something like that, we say it's a partial. But if you go to this example, a part, say a manufacturing company, they're having different parts, components, right? So a part can be a purchased from outside or it could be manufactured inside. So either it has to be purchased or manufactured. They cannot be both together. So it's a disjoint. But there cannot be a part which is not purchased or not manufactured. So it has to be either manufactured or purchased. So there cannot be any other part other than this. So then we'll call it's a full total participation. It's called a total participation.
Participation.
Does it make sense?
Yes, sir. Yes, sir. Fine.
Anybody want to say how do I create the tables? So for person, I
You will
assume
share
a
the
ID.
tables. These tables we will share in the slides, sir.
No tables. There is a tutorial where I have explained all this. Please go
Okay,
for
okay.
that thing. Then faculty. What faculty should have? It can have ID. And say faculty means maybe having some department. I'm just assuming department. And student, it's having the ID and having some class. Now, if I want to query about faculty, I'll basically do a join between the person and faculty. That gives the faculty ID, faculty name and department. If I want to find out the student information, I'll do a join between person and student. I'll get the student ID, student name and the class. Is it okay? Hello.
Yes, yes.
But many a situation, okay. So here you have to keep the table. It is mandatory to keep the person table, but many a situation to avoid the joining, if the information is less, we can also go like this in the faculty table along with the ID. You can also keep the name. It increase the redundancy, but reduce the joining effort. So this is a common practice in case of generalization. So depends on the situation. You may avoid this name as for the first case. If you go for the first case, you reduce the redundancy, so storage space requirement will reduce, but the efficiency for the joining will efficiency will reduce because every time you have to do a joining, the time efficiency will reduce. But then the second time you don't require a joining because faculty having the name inside, but it takes some extra space because this redundant information has to be stored. Anything about this? If you have a total, there is no need to keep a table for this part because there is no part exist alone. So it is enough to keep a purchased part which is having maybe a part ID, part name, and maybe the vendor name. And you can have the manufacturer part which are having the ID, name, and the department which has manufactured this. This part table is not required to be maintained because since it is a total participation, a part has to be either a purchased part or a manufactured part. Part do not exist independently, right? Hello. Am I
Yes, sir.
audible?
Yes, sir. Yes, sir.
So actually I have done.
Fine, sir. Yeah, primary key will be ID, na sir? Here.
Yeah, definitely. Everywhere primary key is the ID. So
ID,
this is the primary key ID. In this case also primary keys are the ID.
All the primary key IDs will be. Yeah.
So only the thing is here I can make this name redundant because every time you want to query, you need to make a joining in the first case. Otherwise, they are the same. But if it is total, there is no need to keep this parent relation because there is no part at all. Like either it has to be purchased or manufactured. Okay. So we have done a lot of this thing. Okay. Anything else?
Yeah, sir, in Saturday session, can you also discuss some amount of that SQL stuff?
SQL stuff. I think on that day we have to do that TRC DRC, right? Anybody, Piyush or anybody?
Yeah, TRC and DRC. Any specific which SQL part which means?
Yeah, you can say specific part of SQL because SQL is a big thing, right? It will take a lot
See,
of time.
specifically that week three actually some or other way, even after practicing some amount, probably not too much.
Okay, we'll
Not
try
getting
to
the
add
full.
some part of week 3. If it is not completed, maybe next week we can have a extra session also to complete that. Right?
Yes, because week 3, I think
I got it. But
etc.
may not
session
be.
was
It will
not
be
there. Yeah.
completely possible on the next class. Let us check out. Yeah, we'll try to do that.
And sir, another question is this SQL is done, right? Till week 3 is SQL, right?
Yeah, SQL mostly is done, but you will learn some SQLs which are associated with a few extra things like a rollback, then transactions. So that won't come inside your programming this thing.
Okay,
That's
okay,
just for
okay.
your information. But for the programming assignment, this is all I think. Yeah, any comments from Piyush?
Hello.
Pradeep?
Yes, yes. So we'll plan 2 sessions for SQL practice. Like we have OP exam it's based on SQL query only. So we'll schedule 2 practice sessions for that based on SQL only. So one after the quiz 1, another after quiz 2.
Yeah, but before quiz 1, if you can have at least one session, right, that will make sense because see, the thing is that not getting a very good grip on that. Okay, if I get something how will we doing that?
Yes, that's right.
Yeah.
So
So I posted several queries in the discourse, and I am getting some response as well, but not sure if I am able to decrypt all those things correctly.
yeah, okay. So maybe next week we can plan one session on SQL. I will discuss with the team and let you know. Okay.
We are learning.
That will be great help.
Yeah. Just for next session on SQL will be. I will discuss that. Yeah. Sure.
Practice session is required because we are learning the fundamentals, but we are weak in practices.
Yeah,
okay. Yes.
I know what to do practice, we don't know at least. What to do practically. We are just copying whatever we taught, we just copy that only.
Yeah, so for practice, we have released 30 SQL practice question, right? So you can try out that.
Those practice assignments, right? Like those
30
practice
SQL
assignments
question. On the portal, we have released 30 SQL question along with the solution. You can check the PostgreSQL resources unit. In that, we have released 30 SQL question for practice. And solution is also there.
This is question part of thing. What we do in the practice assignment based on the lectures. What I mean, suppose SQL, where it will be used in the programming. Example for that. Where it will be used. How will be integrated in the website or like that.
It will be done on week 7. It's
okay.
there.
In the DVMS course, sir.
Yeah.
Okay. Fine. Okay. Thank you.
Okay. Okay. Thank you, everyone. Yeah.
Okay.
Yeah.
Now
Thank you all.
Let us finish today, sir.
Yeah, I'm done.
Thank you.
Thank you.
Okay,
thank
sir.
you very much.
Thank you. So nice session, sir. It is very nice because you explained so nicely.
Okay, I'll sign off. Thanks.
Thank you, everybody. Good night.
Okay. Thank you, everyone.
Thank you, sir.